Alright, so this is lesson 8C1. Here are our learning targets for this lesson. At the end of the lesson, and make sure you have these written in your notes, you should be able to explain in your own words what an arithmetic sequence or arithmetic progression, say two terms for the same idea. So what those are, what an arithmetic series is, and how an arithmetic sequence differs from an arithmetic series. Second, you're going to be finding the sum of a series. And finally, you're going to find the value of the last term or the first term in a series when given information. So let's go ahead and start talking about what an arithmetic series is. So, just as a reminder, and I said this earlier, an arithmetic series or sequence is sometimes called an arithmetic progression. They mean the same thing. You just might hear those names interchanged. So let's look at an example of an arithmetic sequence and see if you can figure out what they are and why they work. So we have u sub 1 equals 15. This is an inductive definition like we talked about last week. So here's 1. So this represents one arithmetic sequence. Okay? Here's another example. Okay, so basically what you should notice about both of these inductive definitions, hopefully you remember, we always start with the starting value. So in this case, starting value is 15. In this sequence, we have a starting value of 22. What makes these arithmetic is that they're either increasing by a constant amount or they're decreasing by a constant amount. So anytime you see u sub r plus something or u sub r minus something, and we're in an inductive definition, that means that it's an arithmetic sequence. Okay, so there's some vocabulary associated with these sequences. So let's go ahead and start talking about that because we're going to turn this inductive definition into a formula in just a moment. So this amount that's being added or subtracted, sometimes if we were talking about a line, we'd say it's the slope of a line. This isn't slope because, well, these aren't lines, they're sequences, but it's the same idea. My sequence is going to start at 15, and then it's going to go up 8, which puts it at 23. Then it goes up another 8, which puts it at 31, and then it keeps going up 8, okay? So in a way, this is kind of the same idea of slope, except we don't call it slope because we're not a line. We call it a common difference. So it's the amount of increase or decrease. So in this case, we could say that d equals 8, okay, because the common difference is 8. That's how much it's increasing by. In this one down here, we could say that d equals negative 12, because every term decreases by 12. So we would start out with 22, and we lose 12, so we're at 10. And we'd lose 12 again, so we're at negative 2. We'd lose 12 again, so on, okay? So d is what we call this number that the sequence is increasing or decreasing by, and that stands for common difference. The other variable that you're going to start seeing in this lesson is a. So when we write certain formulas, we're not going to be writing u sub 1. That's something for the inductive definition. So we're going to be substituting a for that value. So our starting value is going to be u sub 1 equals a. So in other words, 15 would be a. 22 would be a. Okay? So both of these could have an a and a d written instead of the starting value here and the common difference here. Alright, so let's go ahead and move forward. Okay, so we talked about in the learning target that there's a difference between something called a sequence and something called a series. So let me write down a sequence for you. 1, 3, 5, 7, 9. And we could separate these by commas if we wanted to, right? Okay, this is a sequence. Okay, a series is going to look like this. Are you noticing the difference? Same numbers, but what a series does is it separates each term by an addition sign. And the reason it does that is because the definition of a series has to do with summing every term in a sequence, or every term in a sequence together. So when we take a sequence and write it as a sum, it becomes a series, okay? So all about series over here says a series is the sum of all terms in a series or in a sequence, okay? So it's a very small difference, but you should know that when I say series, it means sum. When I say sequence, it's just a set of numbers growing by in some pattern, okay? So a few other things about a series. Series must be finite, okay? So what that means is that if I'm going to have a series and I'm going to try to sum something, sum that series, I have to have all the numbers I need to sum in order to sum them. If I had an infinite series or a series that never ended, I could not possibly find the sum because I wouldn't know what numbers to add together. So that's why they have to end. The other thing is we're going to be talking about n terms. N is the number of terms. So a series contains some number of terms, any number of terms, and the sequence looks like this, beginning with term 1. So A would be term 1. That's our starting value. Term 2, so this would be use of 1. Term 2 is our starting value plus the common difference. Okay, so this would be A. This would be A plus D. And in this case, A plus D, D is 2, because our common difference is 2. So we grow by 2 each time. So in a way, this is 1 plus 2. This one is A plus 2D. This is term 3, right? Okay, so A was 1 plus 2 times D, which was 2, and I get 5. Do you see how this is working? And so on, okay? So this is how we would talk about it. And we say n terms because unless we're given a specific number of terms, we don't know how many there are, so we can use the variable n to represent the number of terms. A real-world example, if you think about the World Series in baseball, they call it a series because they're totaling up how many games each team wins, right? They're adding them together. So, you know, whichever team wins the most games out of 7 is the winner of that series. So if they win game 1 and they win game 3, they've won 2 games. They've added 1 and 1 together. So there's the real world link there. Okay, so let's talk about formulas. So basically, when we have a series, we can find any term that we want. Okay, and one of the formulas we're going to use involves finding the last term. So our formula basically says L equals A plus D times quantity n minus 1. What this means is the last term, that's L, is equal to the starting value, so whatever u sub 1 equals, plus D, which is the common difference, times n. N is the number of terms, minus 1. Okay? And we're throwing that n minus 1 in because if we flip back here, you'll notice that our first term doesn't have a D added to it. Only the second term, third term, and every subsequent term has a D. So we have to say n minus 1 because there's no D on the first term, so we kind of just take that away. So as a reminder, L is the last term, since those haven't been defined yet, and n is the number of terms. Okay, so let's do a little practice here. It says for each series, and we know it's a series because the numbers are separated by addition signs, which tells us we're going to be tallying this or summing it up. Okay, find the last term. So we're going to be finding L here. So I'm going to start by saying, by listing everything I know. I don't know L, so I'm not going to list it, but I do know A. A is our starting value. So our first value in our sequence, our series, is 3. Okay? D is our common difference. So what does each term grow by? So from 3 to 7, well, that's 4. 7 to 11, that's 4. 11 to 15, that's 4. We can say that our common difference is 4 because each term grows by 4. Okay? And finally, n, how many terms are we going to have? Well, if we're finding u sub 30, we're going to make 30 our last term. So 1 to 30 is 30 terms. Okay? So I know you might think that 1 to 30 is 29 terms, but keep in mind that we're including the first term and the 30th term, which means that we're not going to do that subtraction. So 1 to 30, just like 1 to 10 is 10 terms. If you count 10 fingers, you start at 1 and you end at 10 and you've got 10 fingers. If you start at 1 and end at 30, you have 30 terms. Okay? So don't try to find the difference there. So what we're going to do now is we're going to go ahead and plug these in. So L equals A, which is 3, plus D, which is 4, times quantity, N, which is 30, and then our equation says minus 1, so I'm going to take 1 away from 30. Okay. Now order of operations says we have to do what's in the parentheses first. Okay, so we say 3 plus 4 times 29. Do not be tempted to add 3 and 4 together. That's incorrect by order of operations. Okay, so we end up with 3 plus 4 times 4 times 29 is 116. So L equals 119. So the value of our last term, in this case our 30th term, is 119. So we could say U sub 30 equals 119. Okay? Alright, let's do one more practice. This time we're finding term 11. So since that's the one we're finding... Oh, I'm doing math. Can you go with Daddy for a little bit? Okay, thanks, sweetie. Alright, so U sub 11, that means we're finding term 11, and since that's what we want to find, we're going to make 11 the last term. Okay, so let's go ahead and make a list of what we know. We know A, so A is our starting term, our starting value. So our starting value is 25. Okay, our common difference is how this series decreases or grows, and in this case we lose 3 here, and let's just make sure this is arithmetic, because if it doesn't grow or decrease by the same number, it's not arithmetic. We lose 3 here, it's arithmetic, we're losing 3 here, here, and here, just like we would if we were finding the slope of a line. Okay, so our common difference is negative 3, because we're losing 3 each time. And then n, well, we're looking for term 11, so that means we have 11 terms that we are trying to find. So let's go ahead and plug this into our formula here. L equals A plus D times quantity N minus 1. So we don't know L. So we're going to say A, which is 25, plus our D, which is negative 3, times N, which is 11, minus 1. Okay, so this ends up equaling 25 minus 3 times 10. Okay, well if I put this into my calculator, I end up with negative 5. So my last term has a value of negative 5, and we could rewrite this as U sub 11 equals negative 5. Okay, so that's how you find the last term. If for some reason you needed to find the common difference, you could use this formula to do that as long as you knew the last term, the first term, and the number of terms. So you can find L, A, D, or N as long as you know three of the variables. So if you want to find N, you need to know L, A, and D. If you want to find A, you have to know L, D, and N. So this is a pretty useful formula in terms of finding unknown values.